All right. Let's blow that up a little bit. Not much. I assume you want to start with 1?
Yeah.
All right. Well, right offhand, where would you think the center of dilation would be if you were just thinking about it?
It would be like it would be like 5, 2.
If we go from vertex to vertex, which doesn't work because not only has it moved, but there's a scale factor also. Okay? Now, the scale factor is actually easier to figure out than the center of dilation. Hold on a second. See, right offhand, I would think the center of dilation would be right there. But let's examine whether or not we can use the vertexes for the center of dilation. What do I have to do to get from there to there?
Go right 4 times.
What do I have to do to get from here to here?
Go up 3.
And therefore, that distance is not likely to be 4 or 3. Some combination of such. So that's not going to work for the center of dilation. Let's leave that for a moment and figure out what the scale factor is. The scale factor means what's that distance compared to what that distance is? Or what is this distance from C to A compared to what C prime to A prime is? Or B to A compared to B prime to A prime? What do you think that is in this case?
I don't know.
Well, if I take the length of that line, I'm going down 4, right 2. If I take the length of that line, I'm going down 2, right 1. So C prime, B prime appears to be what?
C prime, 2, 1.
Yeah, there's a 2 to 1 relationship there. And that distance, I mean, we could put it through the distance formula, but we don't need to. Because all we need to do is look at this as 2 similar right triangles. Have you studied similar right triangles yet?
Yeah.
Okay. Well, these 2 triangles are similar. Therefore, the relationship is constant of any side versus the other side. In other words, from there to there is 4. From there to there is 2. From there to there is 2. From there to there is 1. So it is a 2 to 1 scale factor. Or yeah, 2 to 1. Now, use a straight edge to find the center of dilation. Well, I'm still convinced that the center of dilation, wow. It's clear to me that the movement of the second triangle is right by 4 units and up by 0 units and a scale factor of 2 to 1. In other words, if there wasn't the scale factor, this other triangle would look like this. Right?
Yeah.
Other than the fact that it's been scaled down. Well, if it looked like this, the center of dilation would be the distance between that point and that point, which is 4 units to the right. And that is what happens to C also. When they say use a straight edge, well, okay, that's got to mean you connect all the vertices. There's B, there's C, there's A. What do you think the center of dilation might be?
5, 2.
Yeah. I gotta think that is probably the center of dilation. In other words, this triangle is attempting to move to 5, 2. It's halfway on its way, and it's been dilated by a factor of 2 to 1. Down. So the fact that they said use a straight edge to find it, there's only one way to use a straight edge in this problem. And that's by connecting the vertices, C with C prime, B with B prime, and A with A prime. And wherever those connect, all those 3 lines, that's got to be the center of dilation.
Okay.
I think. Maybe it will. Do you have answers on any of these?
Okay. I think that's right.
Graph the pre-image and its image given the center of dilation and scale factor. Let's go back well, I can't really go back a second. Yeah, I can. When we had this, now I'm becoming more confident of my answer. When we figured out the center of dilation by finding the intersection of the 3 vertices, now you can kind of see that if I gave you the center of dilation and the scale factor is getting smaller the closer we get to that center of dilation, right? In other words, if I were to draw another triangle, it would be smaller still, the closer I got to that center of dilation. And if I were to draw a triangle out here, it would be bigger. So that's what's happening as you approach the center of dilation, is that the shape gets smaller and smaller based on the scale factor. If I know it's a 2-to-1 scale factor, then that is going to be half of that. If it was a 1-to-4 scale factor, this would be a fourth. All right. Let's go down and do the next one. Hopefully this will elucidate the problem a little bit. All right. Triangle XYZ. We need to plot these 3 points. Okay. There's X. Y is -3 -3. So that's Y. And Z is 1 -3. So there's Z. So there's our triangle XYZ. Dilated from 3, 3, where the scale factor is 1/2. Well, there's 3, 3. What's the next thing I should do?
So
Remember how you get the center of dilation. You connect the vertices. They all go through the same point. In other words, that point right there is my center of dilation. And that probably is that, yeah, 3, 3. And they're saying the scale factor is 1/2 after dilation. So do I need to be to the lower left of this triangle or to the upper right?
upper right.
No. What they're saying is give me the preimage. Well, the preimage must be something like this, such that the new image is half of the preimage. You see that?
Yep.
If it would have said a scale factor of 2, then you'd have been correct. I would have gone to the upper right. Now, how do I figure out the scale factor is 1/2? Well, that distance is 4. This one should be 8. So I have not drawn it correctly. Should have drawn it such that the new triangle is twice the size, and I don't mean an area. I mean each dimension. If this dimension is 4, which it is, then this dimension needs to be 8. If this dimension is 4, which it is, then this dimension needs to be 8. And this dimension from here to here, we don't really care about because we know that it's twice. We don't we don't need that dimension. It's all we need to know is where to put that point and where to put that point and where to put that point. So, graph the preimage. All right, I've done that. Didn't really ask for anything else. Graph the preimage and its image. Given the center of dilation and the scale factor, well, they don't really say for sure, but I'm assuming that's the image, X, Y, Z.
Yeah.
Okay, so this is the image. But the preimage has to be bigger because the scale factor is 1/2, right?
Yep.
Yeah. So this makes sense, the way I've graphed it. I don't know what the coordinates of that point are, or that point, or that point, but I know the distance is 8, 8, and the hypotenuse is going to be twice this hypotenuse. And they didn't ask us to figure out the coordinates of that point. So maybe I'll be able to when I have a little bit more scale, like this one. Yeah. So let's look at number 3. There's H. There's A. And there is T. I'm assuming that's the image. And they want graph the preimage. In other words, that's got to be the image. They wouldn't give you the preimage. They would give you the image.
Yeah.
Dilated from -1, 2. Notice they always have to give us that dilation point. There's the dilation point. Okay. What do I do next?
Wait, isn't it the dilated? Isn't it a positive 2?
Well, this is the next thing you need to do. Excuse me. You're absolutely right. Thank you. I love it when students pick up my mistakes because that means they're paying attention. So the dilation point is actually right there. And the scale factor is 2. So our preimage has to be bigger or smaller?
Smaller?
Yeah. In fact, got to be right there. If I were to take that area and dilate it by a factor of 2, I would get triangle HAT. And we've satisfied their question. We've drawn the center of dilation and we've graphed the preimage.
Yeah.
All right, let's go to 4.
Oh, I did 4, but
Tried to do?
the teacher did 4 with me, but she didn't really do 5. She just put the answers on the board.
Okay, let me just make sure I look at 4 and make sure that I'm on the correct path. I'm 95% sure I'm telling you the truth. All right. So the way she got the center. Hold on a second. She graphed 1, 1, 2, 3, and 3, 1, forming that triangle. And then D1 was 1 1/2, 1 1/2. There's 1 1/2, 1 1/2. And 3, 4 1/2. It's got to be that point. I should use different colors. And 4 1/2, 1 1/2 is that point. If I draw that triangle, well, the scale factor is always going to be the relationship between that distance and that distance. And that is 3 to 2. So scale factor 1 1/2 is correct. It doesn't mean the green triangle is 1 1/2 times bigger than the red triangle. What it means is that every side on the green triangle is 1 1/2 times bigger than the side on the red triangle. And there is a difference. The area is actually 1 1/2 squared. Okay? So make sure you distinguish between what 1 1/2 times means. The scale factor is a linear scale factor. That means each side of the triangle is 1 1/2 times bigger. And to figure out where the center is, yeah, you just, in other words, you take the new point, draw a line through the vertex, the new point, draw a line through the vertex, the new point, draw a line through the vertex, and you get your center at 0, 0. So the way I've been doing it is fine. All right, let's look at this next one. Hold on a minute. Let me get all of the directions. All right, let's start with the image. This time I'm going to use different colors. There's 1, 3. There is minus 1, 2. That's A. B. And C is 1, 1. So there's A, B, and C. And then A prime, let's use a darker color. Let's use green. A prime is 1, 3. It's weird. B prime is minus 7, minus 1. 1, 2, 3, 4, 5, 6, 7. There's B prime. And C prime is 1, minus 5. 1, 2, 3, 4, 5. So that's C prime. So if I look at the new triangle, I can see that it is similar to the original triangle. And the scale factor comes from the distance between that and that compared to the distance between that and that. And that distance is 2. This is 8. So you get a scale factor of 4 to 1. Notice that it would be harder if I had to do it on a diagonal or a line with slope. As long as I can use a vertical line or a horizontal line, then the scale factor is going to be really easy. Okay. The shortcut. Verify that the dilation is a similarity transformation using a similarity shortcut. Well, the shortcut really is the fact that AC is 2 and AC prime is 8. Now, you're right, there's the common angle, SAS. I guess that's the answer. You could also have SSS. No, SSS would be congruent, not similar. So it's not SSS, it's SAS. Okay. Let's go to 6. All right. Hold on. Draw any triangle, JKL, and any point O that lies outside the triangle. And we already kind of know that most centers of dilation lie outside the triangle. It's kind of rare when they lie inside or on the vertex of the triangle. But most of the time they lie outside the triangle. Construct using only a compass and straight edge. Well, let's draw a triangle, first of all. We'll call it J, K, L. And any point that lies outside the triangle, well, how about that point right there? O. Construct using only a compass and straight edge. The new triangle to be a dilation of this with center at O. Well, if it's got a center at O, what's my next step using a straight edge?
Connect.
Yeah, connect the original vertices with O. I know that all three of them are going to cross. Whoops. I know that the original vertices all cross at the center of dilation. Remember, this is my triangle here. So far, I've used only a compass or a straight edge. If I am to use a compass and I want to calculate J prime, K prime, L prime, what am I going to do? First of all, which way do I have to go? Do I have to go upper right or lower left?
Up, right?
Yeah. In other words, I got to construct this thing up in this territory. And it's going to look something like this. Twice as big as the original triangle, right?
Yeah.
So this side has to be twice as big as that side. Let's see what they're asking here. Draw any triangle. I do JKL and any point O. Construct using only a compass and a straight edge. Well, how would I figure out where to place that using a compass?
That's an idea.
Well, you measure the point from the center of dilation. Remember what a compass is. A compass is just for measuring distances. So what I know that if this distance here is equal to this distance here, I will have a dilation of a factor of 2. And that's what they ask for. So set your compass distance from there to there and go an equal distance. I haven't left enough room up here to do it. I'm always on the wrong side of these things because when I first draw it, I don't know which side I'm going to be on. But this satisfies the problem. And I think you can see that if I set my compass distance to measure this distance, then I'm going to have a triangle that is a factor of 2 scale factor. In other words, this triangle up there. And that's why I knew I had to go to the upper right, was because the original triangle is getting bigger. In other words, I'm going from JKL to J prime K prime L prime and increasing the new triangle by a factor of 2. Well, I couldn't do that if I went lower left. If I went lower left, I would end up with a triangle that's a factor of a half. But if I go upper right, I can increase the size of it. Kind of think of it as a screen projector. Let's say you have a movie screen camera right there. You're projecting onto a screen. Well, if I'm projecting onto this screen, I get that area. If I go further away and project onto that screen, I get that area. If I go closer, I get this area. So the fact that our scale factor is 2 means I need to move further away from the center of dilation. And the center of dilation they give us. Or, well, they say you can make it up. I should have drawn my picture something like this, just so it would have all fit. I should have drawn it like this. Now here's my center of dilation. Now, if I draw that like that and extend those lines, now my center of dilation, if I'm expanding by a factor of 2, that has to equal that. So my two triangle has to be about there. And in this triangle, every side is twice the distance from this triangle. You get it?
Yeah.
All right. Bradley, you got any more stuff? That's it?
Yeah.
Okay, well, if that's it, then we can end the session. And,
Thank you.
I always only charge you for the amount of time you use. So, we don't need to go further, and I'll only charge you for 2/3 of an hour.
All right.
All right?
Thank you.
All right, Bradley. Bye-bye.